We already saw several satellite images of cyclones. This is just adding a finer point to it that when a satellite is looking for radiances coming from the surface, a lot of IR images are useful for measuring temperatures and various other things, but IR is also absorbed by clouds, especially when there are layers of clouds. Then the satellite obviously cannot see the vertical structure as well as a radiance that could get through the clouds, for example. And it turns out that microwave frequency signals, radiances from the surface, can go through the clouds, and they are sensitive to hydrometeors or raindrops and so on and so forth. So they can serve special purposes for better observing some aspects of cyclones. So here, tropical cyclone in Lala, which happened in the southern hemisphere, you can see here it's at 12 south, 16 south, and so on. Enhanced, so it's showing geostationary grayscale IR and enhanced IRBD in here, and the polar orbiting microwave 85 gigahertz sensor. So microwave is got specific frequencies, and it's a polar orbiting, so typically it's sensing it at an angle that ends up giving it something like a parallax for observing the eye of the cyclone because of the tilt. And that parallax is basically a displacement between where the eye actually is and what the satellite is estimating it to be. And the distance is dependent on the frequency of the microwave in which it's being observed. So different frequencies of microwave have different advantages. So this is microwave image, and you can see that this is much more featureless, let's say, whereas this one captures many of the nice feeder bands, southern hemisphere, so it'll be going clockwise. Remember that the cyclone in the southern hemisphere goes clockwise. So you have these feeder bands coming in to the eye wall, very clearly seen in the microwave, but it's not, that structure is not captured by the IR, even when it's enhanced using some techniques. This is the TRIM microwave imager. It's at 85 gigahertz image of Hurricane Juliet in 2001. Greens, yellows, and reds indicate heavy precipitation. So you can see that IR image would just show clouds, sometimes the eye when it's very well defined, but these are actually giving you a sense of the rain rates even. Okay, so concentric rain bands near the storm center are indicative of multiple concentric eye walls and are typically associated with intense tropical cyclones. So in the next section we will look at eye wall little bit in little bit more detail, but this is just to make the point that when microwave image is superimposed on the GOES IR image, you get many more features that are identifiable because of the microwave. There are now morphing technologies, algorithms developed where the gaps in the microwaves imagers, because they are polar orbiting, they get maybe something like 2 views at the cyclone of the cyclone, unlike the geostationary satellites. And people have developed algorithms to combine multiple images to produce sequence of morphed and observed microwave images of Hurricane Ivan. There are some caveats here as well as to how these get combined. So here is the brightness temperature with horizontal polarization. Technical words that I'm not going to get into it, but essentially this is another way that the cyclone monitoring and tracking are enhanced, and it's obviously very useful for keeping an eye on where it is headed, how strong it is getting, and so on, especially when combined with the satellite methods for estimating intensities. Here is a conceptual model of the relative parallax errors in satellite microwave images of the 37 gigahertz liquid droplet emissions and location of the eye of Typhoon Jelavat or Helavat, I don't know, in 2000. And here it is the same thing for 85 gigahertz ice scattering. So here it is liquid droplet emissions, here it is ice scattering. So the hydrometeors are sensitive to particular frequencies of microwaves. Red circle is the 37 gigahertz eye position, and the yellow circle is the 85 gigahertz eye position. So you can see that the accuracy here is better because the parallax is, I think, about 20 kilometers here, and it's significantly larger here. You can look it up. I think it's 37 to 50 kilometers maybe. So you can see that this circle that's put in here, and this is by the 85 gigahertz. So the parallax errors are shown here because of this slanting or the non-nadir view of the cyclone by the satellite. Okay, so depends on which hydrometeor or meteor is sending the signal back to the satellite. Okay, so those are the kinds of issues that satellites have to deal with. But once the systematic errors and parallaxes are well established, they can be used with corrections and of course the gap filling with the morphing and so on. Incredibly useful technique, and make for beautiful images for analysis of various aspects and evolution of the cyclones along the way.